Morning. So I'm Brian. Glad to be here for Helm Summit in Portland, and I'm sure you all are too. I work at IBM, as I said, as a DevOps guy for a team of about 8. I know some of you may think that's pretty small, but the previous team I was on before was around 5. All right, let's get started. So 8 months ago, my very small team and I started working on a highly available REST API. And a clear solution to provide such was to host on top of Kubernetes. So with a quickly approaching set of deadlines, a very small team, and large expectations, very few people were left to be geared towards the actual testing and output flow side of things. Though more and more started to help out. I'd like to very briskly go over how we got to where we are and how we got to the way we use Helm, just to get a feel for our situation. As our team started to write Go code for the API and spinning up Docker images and running other microservices alongside the code in Docker Compose, I was quickly tasked to putting together Kubernetes files, initially generating them using Compose. If you don't know, that's Docker Compose to Kubernetes files generation, and also tweaking them, because as you know, Compose may or may not generate a lot of extra fields. We managed to put together an initial staging and production environment using KubeSpray, and then began deploying resources using kubecontrol. Pretty standard stuff. It was proposed that I also look into Helm and whether it could benefit us in our process, and of course, I immediately fell in love. And it made my life just a little bit simpler, and that's all I needed to get started. So prior to my current position, like I said, I was on a team of 5 managing OpenStack cloud site controllers across the globe and using lots of Ansible. So this new tech made quite a lot of sense to me. So if you've ever virtually touched bare metals in your life, you probably know the general workings of an Ansible playbook. But if you're here right now and don't know, congratulations. And please allow me to enlighten you. A playbook usually has many roles. Each role is typically a set of separate microservices, and each microservice has default values, which you can be overridden using a single file or a set of files. So if you manage a lot of environments which have a lot of custom needs and different services and different IPs or whatever, you probably need a core component. So that's kind of how we kind of mapped ours. The core component, which is supplemented by an ems file for each site or environment. So switching gears to Kubernetes and eventually Helm, everything kind of made sense how I kind of wanted it to make sense. Charts were essentially roles or even playbooks in some cases. You had requirements.yaml, which was a set of flags to turn off and on roles depending on site requirements. In fact, it was better because you could write out your environment and you could test it. You could deploy and roll back if it didn't work for some reason. Safe mostly. It was clear to see the similarities, and so here's an Ansible playbook, if you've never seen one, and here's a Helm chart. You can see the similarities are pretty striking, and that's kind of how I approach things. So coming from this background of provisioning sites based on sets of variables, the value.yaml seemed like a familiar set of declaratives, and the charts were easily comparable to individual Ansible roles. each having their own default values. And from this perspective, it was clear to also see that the requirements.yaml was a sort of playbook. And all of this was even easier to relate because it too is in YAML. So people rag on YAML, but we all use it to deploy tons of millions of things. But I get it. You don't want to write YAML, and so don't. Rather, just write it once and be done. And what I mean by that is have default values for charts, which is obvious. We have repositories for charts and default values already set for us. But if you would rather improve those and set your own default values, you can. So let's say you have one chart, your environment, with your values.yaml, where global values are defined for all charts that it requires, but only stuff that isn't defined in the core chart itself. So here, if we take chart W, it has its own default, whether chart W exists in a repository or you're defining that yourself. You can alter those values.yaml so that it makes sense to you. That way you end up with a smaller ems values. So yeah, its requirements are charts that may exist outside of its own chart, for instance, from a repo or wherever. For instance, a core repo where your code also exists. And it can be overridden by external values from your env chart. In this way, it's easy to define your own smart values. And you can write more YAML or you can write less YAML, whichever suits you. So I know this is a lot to digest, but I thought it would be a little easier if it's all on one slide rather than breaking it up and not being able to see the flow. So for instance, on the top left, you can see you have an environment laid out as a chart. Some of its requirements and values on the top and middle right. Here my env chart is pulling in from the community charts for MariaDB and Elasticsearch. I hope you can see that. And being enabled, defining values in the values.yaml based on the environment chart values.yaml. However, it is also building and installing a local file path chart for Jaeger located in the core repo or wherever you decide to host your own chart. And that's where you can set your own custom default values and have your own custom templates if you prefer. One that better suits you, reduces required values or even increases depending, again, on what your needs are. So another thing to note is that in order for this to work right now, you need to set global values. So if you can see on my m chart values.yaml, the global values are actually being pulled into the charts you define in the core chart. So this is what you could call something like a smart chart because you have your own custom default values, and in such you reduce the number of values that you write in your env chart. So yeah, this is about it. This is the basics of creating an environment chart that configures what your environment looks like and which charts it requires and how, which is strikingly similar to what I used to do through Ansible and what I'm sure many of you have. So next, I'd like to talk about CI/CD and the way we use it. However, if there's questions now, I can take some of those to answer, about our process and the way we do this. Absolutely.
How would you compare your approach to the Ubisoft approach of having the logic built into the charts?
So Yeah, we definitely have logic written into our charts. I would say yes, okay. So the way we have a separate chart for each environment. So we have staging, we have production, each one of those being a chart. The values are very similar depending on the microservice. We only replace what values we need, such as endpoints for Elasticsearch or what have you. But the core charts, they stay the same. And nothing really needs to be altered in that way. Does that answer? Okay.
One of the experiences I had with Ansible along similar lines was that you have to design those, what you would call core charts or the underlying roles, well to allow this layering or extension, which is fine if you're writing them yourself, but if you're trying to consume third-party stuff, you sometimes get in the situation where they just aren't parameterized sufficiently to allow you to do this. Is this something you've run into, and what's your kind of approach for that?
So just to understand the question, you're saying that the charts, the core charts, whichever microservices are parameterized, are unsuitable, or?
Yeah, just to give an example, so say you take MariaDB, say, and you want to change, I don't know, the port it's listening on. Mm-hmm. In order to do that, that requires the underlying MariaDB chart to take port number as a value, as opposed to just having it hard-coded. Now, hopefully nobody would do that, but there are lots of configurable elements of all these services that you may or may not have decided to put in a value, and that makes them overridable or not overridable. Does that make more sense?
Yes, that makes sense. So, yeah, I would say if, you typically use a particular port, right? A default port, for instance. That would be your default value for your chart. The chart that's actually defined in the core repo. And for instance, let's say one production environment does not use that particular port. It's easily overridable within the env itself. I haven't run into any issues though. It's easily overridable. It's the inheritance is pretty remarkable when it comes to Helm charts. I hope that answers it. Yeah.
Did you find any specific challenges or advantages in having your entire cluster state represented as a single Helm release?
Not that I can think of off the top of my head. The only real issues were the ones described, similar to Ubisoft, which was not release related. It was our Helm version. We upgraded from 2.7 to 2.8, and we had to roll back. But release-wise, everything's so far been smooth.
Thank you.
Mm-hmm.
How do you manage upgrades when you have your entire site as a single release?
Upgrades for the tiller or the actual?
The actual services. So if you wanted to, say, change a parameter in MariaDB, how can you perform that without impacting everything else that you have deployed?
So I guess MariaDB is a little harder because...
Or any value that you have.
Yeah. So the core charts are essentially entirely parameterized. So let's say I wanted to set the root path for I don't know, Prometheus, for instance, and in one environment it's Prometheus 1 is the root path for the URL, and another is Prometheus 2, whatever. If Prometheus 1 was the default that I set in the core chart, it's easy to override that through the inheritance of the M's. So if you take a look at the top left, we have M's, my M chart and values. In values, I would define global Prometheus URL, or home path, and that takes precedence over the default values within the my M chart.
But when you're doing that, if we say make a change to Prometheus and you upgrade the site, will that not also impact, say, Elasticsearch and Jaeger, which will also roll their release simultaneously? As they're declared via requirements within that master chart.
So you're saying would it affect a different service if you were upgrading another service? We have not run into that issue, mainly because we have rolling upgrades, and whenever we're actually changing our M's, we're probably doing it deliberately, and changing probably one thing at a time. Not that you couldn't change both at a time, but if you did change, for instance, Prometheus, and you didn't want to change Elasticsearch, you wouldn't be changing anything other than the one chart itself. Okay, if that's it, I can move on to CI/CD. Okay, so here we have a basic flow. We have two CI managers, Travis and Zool. So today we're focusing on Zool since that's what does the heavy lifting for us. Maybe you're wondering why we have two CI managers, and that's because we love HA. So if one goes down, we always got the other one. But I will say this, I've had very, very little issues with one or the other. But again, today focusing on Zool since that's what does our heavy lifting. When a dev submits a PR, a webhook is triggered to build a VM with Minikube and Helm installed. First, various tests are run, linting, functional tests, unit tests, everything under the sun. Binaries are built, and we deploy our image into the Minikube and its services. It's a good way of testing our CD before we actually deploy to staging our production. Once a PR has been merged to master, a Zool job is triggered, and once again, stands up another VM with Helm installed. The latest code is pulled into the VM, a Docker image is made, and is pushed off to the container registry or artifactory of choice. And once that is completed, we send a Slack notification just to pretty much notify whether the deployment was good or went bad and rolled back. Same flow is repeated when an admin cuts a release tag. So again, we build the version image, push it up to our registry or artifactory, push it up, pull it down, deploy it to prod environments, and send the report to Slack again. If there's any questions on this, I can take this also.
You're rebuilding the image every time for each of these different environments?
So if you want
You're
to,
rebuilding the image every time for each of these environments rather than build it once and test it in all these things?
so right now we have, we're still in our early stages. We have stage and we have production. So we build our latest image every single time we merge code, push it up to the registry so that you have the latest. But when we don't version every single time. So whenever we think we're in a stable spot, we release our version, and that pushes out to production. So staging is really the only thing that gets the latest image, and what actually gets the stable version, is pushed out to production. Any other questions? Oh.
Do you reuse the staging image in production, or do you rebuild it? It's just a follow-up question on the last one.
So if you, let's say for instance, you just merged code, it was latest, but then right after that you cut a tag, that would be a totally different image, but it would be the same code. Does that make sense?
Yeah, that answers my question. Thank you.
Okay. Any other CI/CD questions, or even the charts? I can take more questions on that.
How do you reconcile your versions between, like, How do you keep your versioning reconciled between source code, the Docker image itself, and then your Helm chart? Or do you use the same version number for across the board, or tag, or commit hash, or?
You're saying, so how do I differentiate environments using different images?
More about versioning, like how you manage versioning, the version of the image, the version of the source code.
Okay.
And then the version of the chart.
Yeah. So the chart versioning, depending on what your chart is, whether it's from the community or it's your local. Local's a little harder unless you're maintaining a Helm repository of your own or pushing up somewhere. But as far as pulling from communities, it's pretty straightforward. But for images, we just, whenever we cut a tag, we push up to our registry, and that maintains the version. You can have multiple versions of, the same image. You have latest, you can have a SEM version, and depending on your chart, your environment chart, the way we have it set up, you can pull in, what particular image you want. The same way that you pull in, Nginx version 1.3, you can pull in your API 1.3. I hope that answers it.
It's kind of related to that question. It's on, with managing your charts and its versions and everything, are you effectively deploying your chart like from Git, like you check out the chart and deploy it from whatever its contents are at that commit in the repo, or are you pushing actual charts out? Because I think that's kind of where that was going, is when do you bump to like the Git tag of your Docker image, and then if you have to publish your chart after that, that makes it like a two-phase process versus just, you update the values in your environment chart and that's deployed.
Right. So the way we are currently doing it is we maintain our charts as needed. Whenever we, for instance, cut a tag, that just replaces a simple line in the Helm chart itself, or actually the M's chart. The M's get pulled into the core charts. Does that make sense? So like we replace one line of code in the M's, the values.yaml, and we build the chart from the core, which pulls in the M's, and that pushes out into the deployment. We don't push up we don't manage a Helm repo of our own. So in a way, we don't keep versions of our charts. It's mostly a deploying technique for us as of now. Any other questions?
It seems to me that the image that you build is not necessarily the same between builds, even if the source code is the same, because dependencies that pulled in might have been updated.
So dependencies on the image. That's what you're saying.
Within the image,
Yeah.
it could pull in a different version of OpenSSL if you don't specify exactly which version
Right.
you're going to pull in.
Yeah, that is true. Unless you lock your dependencies, right? So yeah, that would be the only affecting factor. So for instance, if you are pulling in a different version of that image, you'll when you build it, you will have that new, yeah.
We probably have time for about one more question.
Okay.
Have you ever had to deal with a failed deployment, and how did you roll back with your pattern?
Yeah, so within our deployment scripting, we make sure that everything works before we say goodbye. If it doesn't succeed within a certain time frame, we automatically roll back. But there have been cases, when, for instance, when we upgraded to 2.8 Tiller, that it just broke everything. We have had to manually push out to that prod environment, but I mean that's happened maybe twice in total. So we have a pretty stable state of rolling back. The scripting is pretty good. So yeah, something I'd like to add. Moving forward, I would really like to be able to define releases in a new way, or even just define your chart itself that makes sense so that you can define a release, if that makes sense. And on behalf of the 3 people who have not contributed to Helm, I assure you we are eager to and look forward to. So, well, thank you.